All right, so this is the third class of this oxidation reduction class. So we'll be talking about redox equation, redox reaction now. So you must have watched the video on the definition and examples, then these states. So let's move on to redox equation, however. So that's the next thing we'll be talking about. So because your understanding of redox is going to help us to understand how to balance redox equation without wasting much time. When you say redox reaction, it is a reaction in which both reduction and oxidation occur simultaneously. There is no way oxidation will occur without reduction. Both of them occur together. That is what we mean. So if one species is undergoing oxidation, the other one is undergoing reduction. Let me use our common example. Before that, when you say redox, it means that reduction is happening and oxidation is happening simultaneously. So in a reaction. Now, we said something that oxidation is loss of electron. Loss of electron. So what does that mean? The electron loss during oxidation will be gain during reduction. Reduction is gain of electron, oxidation is loss of electron. So we said that in the previous video, and we said we should remember OERIC. OERIC meaning that oxidation is loss of electron, reduction is gain of electron. Now, what do you now need to note here that is very important? Anytime you hear that something is undergoing oxidation, you hear it as a species. If a species is undergoing oxidation, that species is called the reducing agent. That's very important so that you don't make that mistake. The one undergoing oxidation is called reducing agent, or you call it reductant. Reductant. So it has a reducing power. While the one undergoing reduction is called oxidizing agent, or that is called oxidant. Oxidant. So you need to know these two by heart. And what does that mean? If I have H2S plus Cl2 to give me HCl plus S. In this equation now, like I told you, what is the oxidation state of hydrogen? That's +1. Sulfur here is going to be -2. Then chlorine here is 0. We have done that in the previous classes. You should know I'm determining that. Hydrogen here is +1. Chlorine here is -1. Sulfur here is 0. So let's see. They will now ask you that which one is the reducing agent. So when they ask you that which one is the reducing agent, that means you have to look for the one undergoing oxidation. And from what I told you the last time, I said your answer is never here on the product side. Your answer is on the reactant side. So which one is the reducing agent here? So let's look for the one undergoing oxidation. I said oxidation is defined as increase in oxidation number, Abi. So this one goes from 0 to -1. From 0 to -1, that is reduction. That means this species, chlorine, is undergoing reduction. This one goes from -2 to 0. -2 to 0, that is like -2, -1, 0. So that's an increase in oxidation number. An increase in oxidation number means oxidation. So now, looking at these two guys, which one is our reducing agent now? Very good, that's A2S. So because A2S is the one undergoing oxidation, so it is referred to as the reducing agent. Why this one is referred to as the oxidizing agent? So for clarity purpose, why do we have to call the one undergoing reduction? Why do we have to call it the oxidizing agent? Is because there is an electron loss in all of this case. The electron loss at a point is gained by 1. Chlorine going from 0 to -1 shows that it has gained electron. If you remember, it goes -1 means it has gained electron, 0 means it was neutral. Chlorine can go like this, 2,8, 7. Then when it gains 1 electron, it becomes Cl minus, and that's going to give us 2,8, 8. So that means it has gained 1 electron. 1 electron has been added. So from what we have here now, going from 0 to -1 means it has gained electron. That's why we say it's undergoing reduction. But the electron gained by chlorine, where did it come from? It came from sulfur. So sulfur lost his own electron, and eventually sulfur became, because -2 here means that there's excess of electron, and going to 0 means that it has lost those 2 electrons it gained before. So at the end of the day, this one is undergoing oxidation, because loss of electron is oxidation. So look at it again. Why are we now calling this one oxidizing agent? Because if this one did not lose electron, this will not have gained electron. So this is an agent that brought about the reduction of this one. So reducing agent is an agent that brings about the reduction of another thing. If you say house agent will help you get house. So reducing agent will make another species to become reduced. Do you get that? So this one is an oxidizing agent because it's making A2S to become oxidized. Why? Because it accepted the electron loss here. So it accepted the electron and this one became oxidized. It became reduced. And that is what we want to talk about in this place. So don't forget, anytime they say which one is a reducing agent, just look for the one undergoing oxidation from what we have learned in the previous video. So the one undergoing oxidation is this one, and that means that is your reducing agent. If they say which one is the oxidizing agent, look for the one undergoing reduction. That is your oxidizing agent. And let's say you don't even know what to do at all. Don't pick your answer on this side. Your answer is always on this side. So we are going on to balancing redox equation in acidic medium and in basic medium for the purpose of your exam. So if you're here to subscribe, please subscribe to the channel. Click on the subscribe button. It's not going to cost you anything. It helps you to promote our videos and get it to a whole lot of people, while you also get updates anytime we upload a video. So thank you.